So I will give a brief status report on our project on the automatic exchange of sample metadata between homelab, IceBear, and synchrotron ISPyB. So it was an Instruct-ULTRA Call 1 project, which was done by ourselves in Oulu in north of Finland, together with Joel Sussman at the Weizmann and Alan Ashton at Diamond. And IceBear is a software package. It's an acronym that refers to importance of crystal data tracking, education, and research. And it is developed in our faculty by Daniel. And so what we needed was user-friendly software to monitor our crystallization experiments. So we have a formulatrix RI54 in the cold room and in room temperature. And the setup is that IceBear collects all the images that are taken by these images. And this is complemented by the metadata with respect to the crystallization screen, which protein concentration and protein buffer, and also what kind of protein it was in the sequence, for example, is also part of the metadata that is stored in this database. So this software was quite user-friendly and quite robust. And so then we tried to expand into another utility, which would be quite useful, which is that if we send crystals to synchrotron, is it possible to send the metadata to ISPyB without any human intervention? And so that we have been working on. And what is now available is that for every sample that is sent, the metadata can be uploaded automatically. We get back from the Diamond ISPyB where the link is, where the diffraction information can be found. And this protocol has been tested at several Diamond rapid access data collection runs. And so Ed had to make several new modules to get this to work. And an important module is this Cryo Freezing GUI. That is what is used and available as a terminal window on the crystal mounting bench. So if the researcher freezes the crystal and puts it on a pin and a puck and a dewar, then it's a simple movement by the mouse or by touchscreen operation to inform the database which crystal is going to what pin, what puck, and to what dewar. And also on this workbench, there needs to be a good barcode reader to inform the system which plate is being used and what pins and pucks and dewars are available. During freezing, it's also possible to add notes. At the end of the activities of preparing the shipment, IceBear provides a shipment manifest, which is a PDF file, which has QR codes either to the crystallization information or to the diffraction information. And this shipment is, this data, PDF file is stored in the IceBear database, and it can also be printed out and used for making notes. Another new module is the crystal page. On the crystal page, it can be found by various search options. And if you have reached the right crystal page for the sample you're interested in, you can either go to the one click away is the crystallization condition. And here is the click for the getting to the diffraction information. And that really works. And so when you are coming to the refinement of the structure, you can go back to the diffraction information and check questions about resolution, radiation damage, or whatever other question you might have. So this was a successful sample, could be processed by various data processing pipelines. It could not be processed by the downstream processing pipelines, which means molecular replacement and so on, because we are not yet able to upload the sequence structure or ligand information. On this crystal page, you can also, when the structure is finally deposited, provide the information what PDB entry has been generated. And if you click on that link, you can reach the PDB page, and there are links to various other web pages with information on this structure. So the advantages of this protocol is that there is an error-free exchange of metadata between homelab and synchrotron. There is then an easy access of diffraction information as well as crystallization information. And I think it works as a good educational tool. At the university, all the time there are new people coming in, and the software asks the right questions, and if the researchers provide all the information, then this is available for discussions with the supervisor or later on for writing manuscripts. It's obviously also good for research data management, which is nice if you want to check back what a certain PDB entry, how it was generated. But I think also at the intermediate stages, when people leave and new people come in principle, all the information is then available when you go to the particular sample and want to continue with the refinement. So the current status is that it's installed in Oulu, Helsinki, Turku, and Weizmann. Finland, Academy of Finland is now supporting it, and through that effort, we tries to install it at the CSC, which is a central computer center. And the idea is to generate a cloud service, and it's already partly working. For example, it's a demonstration server, it's running at CSC. We have now also interactions with MAX4, and this week a successful upload of metadata has happened. And there are also interactions with ALBA and ESRF. There are all the time interactions with the ISPyB developers. It's a nice community, and we interact with them trying to get harmonized access to the synchrotrons, and also hopefully in future able to upload sequence structure and ligand information. Ed has made a project website which you can find easily, and on the project website there is a link to the demonstration server. If you play with the software, please let us know feedback and suggestions how we can improve it. This demonstration server is reset every day at the end of the day, so the database is always fresh the next morning. So you can change the database without any additional trouble. So this has been quite an extensive project with many people involved. Ed has developed the software together with the researchers of Diamond. Diamond has supported this quite a lot. And also important for us was the interaction with Joel Sussman at the Weizmann. Actually, the first time that the automatic shipment was working was when we visited the Weizmann. Locally, several senior researchers are working on this project, and also users in Oulu and Finland are contributing by giving feedback. Also, I would like to mention the ISPyB developers community. They have regular meetings, and attending these meetings. And finally, I would like to thank Ray Owens and Naomi for taking care of all the administrative work in such a way that we could develop this deliverable. Thank you.